Home from Cal Poly, got the week off. All right, here we go. I got $3. All right, so x plus 3 to the 4th power. Can you do? Yeah, it seems like a pain. Seems as comment is a good one. Why exactly?
Show us the shortcut.
Exactly. We want a shortcut, and that is exactly the point of today. We don't want to do that by hand, right? I mean, in a minute they're going to give me like 10th power. And I do not want to do that by hand. I mean, you could do 4th power, I guess. You could write 4 of them and FOIL it all out. But there's a better way. And the better way is called the binomial theorem. Bi meaning 2. It's for multiplying 2 things a whole bunch of times. The x and the plus 3. That's 2 things. Binomial, like bicycle, 2 tires. Binomial, 2-termer. So if you have a 2-termer that you need to multiply a whole bunch of times, there's a formula for just jumping right to the final answer without doing all the foiling. Let's do the foiling, how about, one time, and then we'll really appreciate the formula. So it means x plus 3, times x plus 3, times x plus 3, times x plus 3, right? How about I FOIL these two? What do you get? X squared plus 6x plus 9, that good? Then I'll multiply these two. X squared plus 6x plus 9, that good? And then I'll FOIL the whole thing together. Are you tracking with me? So I'll take this x, go boom, boom, boom. X to the 4th plus 6x cubed plus 9x squared. He's done. Next one. The x, 6x, boom, boom, boom. So that'd be 6x cubed. Come on. 6x cubed plus 36x squared plus 54x. And finally, the 9 goes to all 3, and you get 9x squared plus, I don't know. Wait, why don't I line these up? Well, it's too late for that. 9x squared, I'm getting lost. Where am I? Oh, 54x plus 81. There we go. This is a pain. Gather all the like terms. X to the 4th, 6x cubed and 6x cubed, 12x cubed. 9x squared, 9x squared, that's 18. 36, what's that? 20 be 56, 50, 54. I just add 20 back up 2. Easy way to add 18. 18 plus 36 would be 56 back up 2, 54. X squared, 54x, 54x, 108x plus 81. Which answer is that? Is it B? B it is. We got it. Next problem. No. So that would be the by hand way.
No, it's not B, because B has 8x to the 3rd.
Oh, you're right.
Come on, Mr.
I'm looking
Aaron.
cool. Yeah.
So it's D.
Is it D? Yeah, D. Okay, I've changed my mind. It's D. That good? All right. We don't want to do it that way, especially when they go 10th power. It would be horrible. So we need a formula. The binomial theorem. All right. So having done it the hard way, well, it actually wasn't too bad with 4th power, but it's going to get, worse, like I said, for 10th power. So let me give you the binomial theorem. So basically, here's what it is. The terms go this way. You start with, what's the high, let's go back in. What's the highest power term? X to the 4th. That makes sense because it's, x to the 4th, right? So that's going to be the highest power term. So come over here and write x to the 4th, then go below it, x to the 3rd, x to the 2nd, x to the 1st, x to the nothing. Those are the different terms you're going to have when you FOIL it all out a whole bunch of times. Let me go back and show you, right? Didn't I have x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then no x at all? Or x to the 0, in other words? This one's x to the 0, isn't it? Y'all with me? See how those were all... I'm just writing them vertical instead of sideways. Right? They're going to be like that. Now, next to them is going to be... So that's the x. It's binomial, 2 terms. I took the first of the 2 terms, and I did him... 4th, 3rd, 2nd, 1st, nothing. What's the pattern? Math is all about patterns, right? So now I'm going to take the 2nd term, the plus 3. It's binomial again, 2 terms. I did the first one, the x. Now I'm doing the positive 3, the second one. And I'm going to do the same thing with him, running reverse order. Meaning start down here, go plus 3 to the 4th, plus 3 to the 3rd, plus 3 to the 2nd, plus 3 to the 1st, plus 3 to the 0. This is the pattern. I'm giving you the pattern of the formula, the binomial theorem. Everybody see what I did there? So you just start with whatever comes first in the parenthesis. Right? We had an x and then a plus 3 to 5. I just take the first guy, x, and I go 4, 3, 2, 1, 0. Then I grab the second guy, the plus 3, and run it up backwards. 4, 3, 2, 1, 0. Multiply together. Good so far? One more piece of the puzzle. But it's a complex piece. That is, you do this parenthesis thing. I'm going to explain it in a minute. And you start with the power, the 4, and you put a 0 kind of floating down below. It's not a fraction. That 4 and that 0 are vertically floating. It's combinations is what it means. 4 combinations of 0. 4, and then go 4, 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. And then I got to show you what those things are. If we can do those will each turn out to be a number, which we will calculate. The 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. They're a number which we will calculate. Let me show you how to calculate those numbers. I'll give you 3 different ways to calculate those numbers, and you can pick your favorite. The first is you can just use your calculator. That'll probably be your favorite. 4, 0 means 4C0 on your calculator. If you know the combinations, so 4, 1 means 4C1. Now, where is that on the TI-84, for example? It's under math probability. So if you hit the math button on your TI-84 and then go to the right arrow over to the PRB screen, I think it's down there, right?
You can also get to it by second and then hit catalog.
Okay, and then look it up.
And just put N on top of the log, and it'll take you directly to the NCR.
Okay, couple of ways to get there. So I think the quickest is the math, and then go to the right under the probability. But you got to enter the number first. So you put a 4 on your screen. Before you ever get that up, put a 4 on your screen. Then hit math, and then right arrow 3 times over to the PRB, probability menu, and go down to the C, the NCR. Hit that, and it'll put the C on the main screen, and then put the 0, and hit enter, and you should get 1. This right here is 1. And then do 4, 1, you'll get 4. Do 4, 2, you'll get 6, I think. Yeah. And then do that one, it's 4, and that one, it's 1. See if you can get 1, 4, 6, 4, 1. Doing that C thing every time on your calculator.
How did you get the 4 and 0? How do you put that?
So you type in, you literally put 4 on your screen, your main calculator screen.
4.
Then go find the C thing.
Put the probability down to the third.
Oh,
And,
and that opens it up. Okay.
Everybody get
There'll be 2.
Alex, can I use your calculator for a second? I'll put it up. Here, let me put it up. I forgot mine, as usual. Here, I'll put it up here real quick. Okay, so
Where did you put that?
So 4.
okay, so I put a 4 on the main screen. See that? So you first put your 4.
I clicked.
Then you hit the math button. I'm going to hit math. And see that menu? Go over to the PRB menu. Go down. There it is, NCR, number 3. Hit enter. And now it's got 4, NCR, 0, enter. It's 1. And etc. Is that good? So that's one way, using the calculator. Thank you. There we go. All right, so, and now a second way to make this happen is with the, I can just tell you what it means. When 4, let me do like the 4s too, it'll make more sense. The first number is what you start with. The second number is how many numbers. How many numbers? So you start with 4, do 2 numbers. So this is by hand. Start with 4, do 2 numbers. So 4, going down. So 4 times 3, divide by second number on down to 1. 2 times 1. 12 over 2, 6. That makes sense? Can you guys explain later, please? Right, we good there? 12 over 2 equals 6.
I understand.
Good. So see, did everybody see? This is the by hand way. So the first number is your starting number. The second number is how many numbers? Start at 4, do 2 numbers. Divide by, so let me just write, divide by second number on down to 1. That's a by hand way. Divide by second number down to 1. So for example, what if somebody gave me, I don't know, 8, 3? What would that be? Remember, the first number is your starting number. Second number is how many. It's your how many and you divide what you divide by. So start at 8, do 3 numbers. Is that good? Divide by the second number on down to 1. Does that make sense? So whatever that comes out to be, 56. You can tell because 6 cancels 6. 56. 7 times 8 is 56. Is that good by hand? If you don't have your calculator with you or you don't have your graphing calculator. So everybody see what I'm doing there? That top number is your starter. The second number is how many numbers. You always go down. It's like factorial where you go down. You know, so start at 8, do 3 numbers, divide by second number on down to 1. So now the 0 thing is weird. Just remember 0 is always 1. Anything with a 0 is always 1. What would be 4 choose 1? We'll start at 4, do 1 number. Okay, I did 1 number. Divide by the second number on down to 1. I am at 1. 4 over 1 is 4. That's why that one's just 4, right? So there would be the by hand way. Is that good on that?
The by hand, you're doing the same thing as the C and R, right?
That's right. I'm doing the same thing as NCR.
I understand that.
So we got NCR by calculator. We got NCR by hand method. And lastly, let me just erase it and do it right here. You can do NCR by, anybody else know? What's the other method?
Pascal.
Pascal's triangle. Exactly. Who was Pascal?
The painter, right?
Is he a painter? I don't know if he's a painter. Philosopher, mathematician, all that kind of stuff. Yeah, good thinker. Pretty good thinker, I think. Very good thinker, I think. All right, anyway, so he had a triangle. Start with 1, make these 1s down the diagonal like that, and put 1, and then what you do is you just keep doing 1. You're making it like a little Christmas tree. It's Christmas. I'll use a Christmas analogy. You're making a Christmas tree, and the 1s go down the diagonal. You know, you're asking me how many daughters I have in my house, and it's true. And now it's Christmas season. They want to constantly watch Hallmark movies on TV. And my sons and I are like, always the same story. How many of these do we need to watch? We can tell you what's going to end. 10 minutes in, here's how it's going to end. It's going to go just like this. I mean, it's just a little bit old, but the girls like those movies, and my wife. All right. So anyway, that's my Christmas woes there. So Christmas tree with the 1s there, and then they add, what we're going to do with those 1s now is we're going to add and what comes below. So 1 plus 1 is 2. Okay, to another layer of 1s. 1 plus 2 is 3. 1 plus 2 is 3. Makes sense? We just add, that's Pascal's triangle. You add 2 things to produce the thing right in the middle below them. Keep going 1s. The outside is just a Christmas tree of 1s. 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4. Look at them. There they are. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1.
But I don't understand why we're doing that.
That's a third way of getting what these numbers are. So I'm giving you 3 different ways of how to compute the NCR. NCR by calculator. NCR by hand, start at 8, do 3 numbers, divide by. And the third way is Pascal's triangle to get these numbers. We need to know what these numbers are in front of the coefficients.
I don't understand why you're looking for those.
We need to know, listen to the sentence, we need to know what these numbers are in front of the coefficients. I need to know what that is. I got to finish this problem. So I need to know this is a 4. I mean, I already know by 2 different ways, right? I already know this is a 4. But I need to know, so I'm just showing a third way to get those numbers. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Does that make sense? So that's the third way. So that's Pascal's triangle. So any of those 3 ways will work. So now we have all the coefficients. This is a 1 times x to the 4th times 3 to the 0. That will tell you the x to the 4th term. So what does that come out to be then? That is 1 times x to the 4th times 1. Does that make sense? The next one is 4 times x to the 3rd times 3, which is going to be 12x to the 3rd. That makes sense? And the next one's going to be 6 times x to the 2nd times 9. 6 times x to the 2nd times 9, which is going to be 54 x to the 2nd. This one's going to be 4 times x times 27, which is, I guess that's the 108 number.
Yeah.
And this is 1 times, oh, x to the 0 is not x, it's just 1, huh?
Yeah, 81.
And 81, so that's just your 81. There we go, there's the terms. That produces the term. So to find so there's the whole binomial theorem. What do you do again? You got two things, binomial. You start with the first one, you go 4, 3, 2, 1, 0. First one in the parenthesis, the x. And then whatever second in the parenthesis, plus 3, backwards, 4, 3, 2, 1, 0. And then you put in the front this choose thing. And you can compute what those numbers are one of those three ways. And then just put them all together. We've got the binomial theorem terms, which is actually more work than just doing it by hand when the power is only fourth power. But when it gets higher, this is helpful. Is that good? Does that make sense? Green. Push. Okay. So we're going to take, so everybody with me, you take the 4x and you go to, what power do we start with?
0.
5. Well, the other thing will start with 0. So 5, 4, 3, 2, 1, 0. Is that good? 5, 4, 3, 2, 1, 0. And then backwards, you start with the plus 1, and you go 5, 4, 3, 2, 1, 0. Everybody good with that so far? So just first term, second term, and now do the choose thing in the front. All right, so the choose thing. And what number do we start with the choose thing? Again, it's always the power. You're always starting with the power, whatever that power is. So 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. But you got to figure out what those numbers are and multiply all the numbers together to find the coefficients. So use your calculator or the Pascal's triangle or the by hand method, whatever you like, to figure out what those coefficients are. The first one's always 1. This is 5. This is 10, isn't it? Oh, and by the way, they're always symmetrical. So once they start to repeat, you know the rest. You only have to do half the list. They always repeat. Does that make sense? Sometimes they have 2 in the middle, or last one had 1 in the middle. So it's 1, 5, 10, 10, 5, 1. It's all symmetrical. So then you can multiply those together. Give you a second. Use your calculator. Finish that up.
Professor Herron,
Yeah.
would it be a true statement to say that where 4x, that location there, starts by decreasing and whatever's in the 1 location it always increases?
Yeah. You're saying the 4x starts at 5 and goes down, decreases. The other one starts at 0 and goes up. That's another way to say the same thing.
One goes down.
Yeah. Yep. That's another way to say it. Yep. So what do we got here? We've got 1 and then 4x to the 5th. What is that? I don't know. Big, huh? Is it 1024? Is it 1024?
Yeah.
X to the 5th times 1. I'm kind of out of room here. I'm going to have to put it. I'm going to have to put it. Well, I'm going to have to squeeze it in there, I guess. So it's 1 times 1024 x to the 5th times 1. It's 5 times 256 x to the 4th times 1. And this is what, 10 times 64 x to the 3rd times 1. This is 10. Oops. I'm running out of room here. This is 10 16x squared times 1, 5 times 4x times 1, 1 times, oh, anything to the 0 power is 1, huh? 1 times 1 times 1. So what's all that? So what's this first one here? Just 1024 x to the 5th. What's 5 times 256? 780? No, I'm way off. 1280, thanks. 1280. Everybody see how I'm coming up with these numbers?
Yeah.
I'm asking you what they are. No, I am doing that too. But I'm just getting them right there, right? So it's whatever 5 times 256 is, and then 10 times 64. That one I can do. 640. Oops, but I can't write it. 640 x to the 3rd plus in this one 160 x squared. 20x and 1. Is that B?
Yeah.
All right, B it is. There we go. We just did that, multiplied 5 times, and there's the answer. Does that make sense? Questions I can answer on that? Is that pattern making sense? So again, you get two things, binomial, you got a 4x and a 1. Take the first thing, 5, 4, 3, 2, 1, 0. And then the second thing, starting from the bottom, 5, 4, 3, 2, 1, 0. And then goes in the front, you start with 5, 0, 1, 2, 3, 4, 5. Figure out what those are and multiply them all together. That's the binomial theorem. All right. I move on from that. Y'all got that down? So, root of x. Uh-oh, what was it? I forgot it already. Root of x plus root of 5 to the 6th. And that was number 6. Number 5 to the 6th power. Yeah, okay, yeah, there it is. All right, so there it is. Want to try that one?
Not really.
Yeah, not really, maybe, huh? All right, let's see if we can do it. That's a 5. My 5s look kind of funny.
Will the root ones be on the exam or no?
Yeah, it's fair game.
How many?
There'll probably be 2 binomial questions. One forward, one where you jump. I'll show you in a minute. We'll do the jump ones. So give it a try. So take the first one, the root x, and go 6. Remember, you start with 6 this time, right? The power 6. 6, 5, 4, 3, 2, 1, 0. And then grab that second one. Start at the bottom. 6, 5, 4, 3, 2, 1, 0. Good, that working out. So then you do the second one. Well, I start at the bottom. First power, second. Oh, it's supposed to start at 0, huh? Yeah, you can just go 0, 1, 2, 3, 4, 5, 6. Either way you want to do it. You can always double check. The 2 powers like 1 and 5 always add up to be the 6 total. 2 and 4, 6, 3 and 3 is 6, 4 and 2 is 6. It's a good double check. The powers should add up to be the total power on the binomial. They always will.
Wouldn't the square, the invisible 2, divide the 6? On the square root.
Oh, right, and yeah, we'll do all that when we work out the roots in a minute. That is true. So, and now we got to put the choose thing in the front. So 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6, like that. And now, yeah, we got to figure out all those different parts. I should have left more room. So the 6 choose 0, that's 1. So you could use your calculator or do the by hand or the Pythagorean or Pascal's triangle. It's 15, isn't it? I don't know that one.
20.
What it is? Thank you. 30. Yeah, I know it goes back now. Yeah, once you get a repeat, it goes back. See how it's always symmetric? 20, huh? 30. Oh yeah, it is 20. Yeah. Okay. All right. So good to there, and then now we got to simplify that. That's not easily simplified. And I don't got room right there. So here, everybody good to there? Everybody good with the pattern?
Yeah.
To there. Okay. So now, what is the square root of x to the 6th power? What happens with square roots?
X 1 6.
Yeah,
X 1 6.
every 2 of them sends 1 out, huh? Remember that? Right? So what you really have is, 6 of these guys. Oops. 6 of them. And every 2 makes a regular x. Remember how square roots work? 2 for 1 deal at Target. Christmas shopping this Christmas at Target. Everything's on sale, 2 for 1. So 2x is in, 1x. That's what's called a square root. Square means 2, huh? Right? Third cube is 3. Square is 2. So square root, 2 for 1. So that means these 2 x's make 1, these 2 make 1, these 2 make 1. So it's going to be x cubed for that first one. The 1 in the front and the 1 in the back. So the first term is just 1x cubed. Good so far? The second term is going to be root x to the 5th. So what's going to happen when you have 5 of those? You get 2 and 2. It's going to be x squared with 1 left inside. That's right, because these 2 make an x, these 2 make another x. That's x squared. This one's left inside because there's not 2 of them. So x squared root x for that term. The number in the front is a 6. The number in the back is root 5. So usually we just put the numbers together. So 6 root 5 x squared root x. That's the second term. 6 root 5 x squared root x. Now the third term. Now we have 4 root x's. What's 4 of them going to do? X squared. Got a 15 in the front. What do we have at the back? Root 5 squared? Just 5, huh? These are all multiplied together. 5 times 15 is 75. 75x squared for the third term.
Pretty easy.
Not too bad once you got the pattern. Next one is going to be 3 of the root x's. Those 2 make a regular x, so it's x squared root x. Like that. And we got a 20 in the front. And we've got root 5 to the third in there. Now what's root 5 to the third? Maybe I better write that out. Root 5, root 5, root 5. 2 root 5's inside. It's 1 5 out with 1 left in. Let me make that smaller. Everybody good with that? Right? So the 3 root 5's, 2 root 5's make a regular 5. The other one's left in. So what do we got there? 20 times 5, that's 100. Root 5 x squared root x. That's a complex term. 100 root 5 x squared root x. See what I did there, multiplying the 20 and the 5? Good. What's the next one? Root x squared is just x. What's root 5 to the 4th?
Isn't it 5 root? Isn't it root 5x? Because it's 5 root 5.
What's that?
On the 20, it's 5 root 5, isn't it?
Right, it's 5 root 5, but that 5 multiplied that 20 that was in the front to make 100. Yeah, so they made the 100.
So you couldn't just put them under the same root?
Oh, the 5 and the x? You could, actually. Yeah, that's another way you could do it. Yeah, that's probably, they probably do it that way, now that you mention it. They might. Either way is totally right. Yeah. Now, we'll look back at the answer. They might have done it that way. Okay, so on this one, 2 root 5s make a regular 5, and 2 root 5s make a regular 5. 5 times 5, 25, huh? So it's going to be 15 times regular x times 25. Whoops. It's a shaky looking 5 there. All right, on that one, what's 15 times 25? 250 and half that. 375?
Yep.
375x, like that. We're good there. And then 2 more. 5 root 5s now.
25 and a root 5.
Yeah, right, because these two make a 5, these two make a 5. 5 times 5 is 25 with 1 more root 5 left. And then 6 in the front. And this is just root x, so just root x. And so that's 6 times 25. 6 quarters is $1.50. $1.50 and root 5x. We'll do Seema's method here. We'll just put the 5 and the x together under the root. Either way is fine. Lastly, this is just 1. This is 1, so it's 1 times 1. Root 5 to the 6th. Yeah, it's 5 to the 3rd, effectively, isn't it? These two, these two, these two. It's 5 times 5 times 5, 125. Whew, there we go. There's the terms from the binomial theorem. We good on that? It's a little tedious. All right. Take one other. Okay. So they say, so now they're really not wanting the whole thing. They're just saying, hey, if you did the whole thing for this, for 2x minus 1 to the 10th, if you did the whole thing, what would be the coefficient of x to the 4th? They're saying, just give me the x to the 4th. This is what I'll do in the exam. I'll give you one where I ask for the whole thing, and I'll give you one where I say, just tell me the x to the 4th. Or I might say, just give me the 3rd term, whatever that is. And they'll ask one of those, number 10 or 11 will be one like that. All right, so how do we do that? Well, it's kind of nice. We don't have to do the whole thing. We just have to do the part they're asking for. But the whole thing is in a pattern. So you probably kind of want to start the pattern and then just get to the one you need and then just get that one. So let me show you. How would you start? Well, you start the first binomial. So the first player in the game is the 2x. And so let me just do it right here. We'll take the, right here maybe. We'll take the 2x to the 10th, 2x to the 9th, 2x to the 8th, which I'm going to run out of room here, aren't I? Put one more up here. So 10, 9, 8, 7, 6, 5, 4, 3. Now that, oh no, 4. I need the 4, so I'll stop at the 4. All I need is the 4th power, right? So this is the one I need. This is the one I'm looking for. 2x to the 4th. We get there. Now, what does that mean about the second term in the binomial? Careful, it's negative 1, huh? It's not just 1. It's an easy mistake to make is say it's just 1, but it's negative 1. Okay, so we're going to have negative 1, and it's going to be to various powers. Now, how do you know what power? It starts at 0, doesn't it? Starts at 0, 1, 2, 3, 4, 5. So this has got to be 6. So this is the one we're looking for. And it makes sense because 4 and 6 make 10. Remember how the powers always had to be the main power? Like that. So that's, I probably could have just thought that and wrote it down without writing anything else down. Good. And then what goes in the front? Now we got to put the things in the front. Starts with 10 because that's the main power. 10, 0, 10, 1, 10, 2. If you want to just jump there, you can see it's always going to be, this is always going to match that, isn't it? See all the patterns everywhere? It's going to be 6, isn't it? But I'll finish it up. 10, 4, 10, 5, sure enough, 10, 6. So there's the term we want. If we can just figure that out now, we've got the one they're asking for, because that's going to be the x to the 4th term. All right, so what is that going to be? Well, it's going to be 10, 6. If you do your calculator, 10, 6, 10, 4, I don't know. 10, 9, 8, 7. I don't know, I can't do it. Somebody got 10, 6? 210? Thank you. This one's 210. So it'll be 210 times, and then 2x to the 4th, that's 2 to the 4th. Is that 16? 16? And then negative 1 to the 6th. What's negative 1 to the 6th? Just positive 1, regular 1, huh? So multiply those all. What's 16 times 210? Some big number. What is it?
3,360.
3360 x to the 4th. We're able to find, it's kind of powerful that we can actually find the x to the 4th term in whatever that would be multiplied out 10 times. You imagine doing that all by hand and trying not to mess up?
I'm good.
All those negatives everywhere? And this jumps us right to the answer. That, that's, if you ever wonder, like, what is math? Or every now and then I like to just be philosophical for 30 seconds. Math is the power of patterns. That's it. All of math is the science of patterns. Studying math makes you better and better at looking for a pattern, following a pattern, predicting a pattern, describing patterns. By the power of a pattern, we're able to jump right to there. It's all in the binomial pattern, isn't it? That's math. Math is the power of patterns.
We would input that in the computer programming to figure out large sums of data, right? In computer programming, they input this formula.
Right. They could put the formula right into a program, right? That's right. All right. We better do one more. Is everybody good with that one? 3360. Okay, so you see how this question is slightly different than the last? I may ask either one of these versions. I don't even remember, to tell you the truth, what to put on there. But they're saying 2x minus 3 to the 8th, and they want the 4th term. So they're not saying I want the x to the whatever. I want the x to the 7th term or the x to the 4th term. They're just saying 4th term. I don't even know what the power on the x thing is going to be. That's a little bit different, right? This last one, they said, give me the x to the 4th coefficient, which was the 3360. Right? Okay, so 4th term. So that means you just got to start with the 1st term, just go 1st, 2nd, 3rd, 4th. When you get to the 4th, stop and figure out the 4th term. I'll give you a minute there. Figure out the 4th term.
This will all be on YouTube, right?
Yeah. Yep. But you're right here, getting it live. You don't need YouTube, do you? Just for entertainment later. So this is the 1st term, 2nd term, 3rd term, 4th term. Finding that 4th term. And then what goes here is the other thing. Careful, it's negative 3, huh? And then what goes in the front is A0, A1, A2, A3. We're good to here. So there's the fourth term. You guys get that by the pattern?
Yep.
On that, now we just got to figure those parts out. Is it 56?
Yeah.
Yeah.
56, and then 2x to the 32, x to the 5th, and then negative 3 to the 3rd is negative 20. This can come out negative, isn't it?
Yeah.
So we'll get whatever. What is 56 times 32 times negative 27? It's negative something.
Negative 48,384.
That's what I thought. No, I'm just kidding. I have no idea.
Excellent.
Is that good? Look at that. You imagine trying to multiply that thing out 8 times and find what the fourth term is?
I would get that.
The power. Me too. Me too. It's the power of a pattern. That's the power of math. The power of math is a pattern. That's how we just did that, right? The binomial theorem is nothing but a big fancy pattern. That's all it is. That's what math is. What is the role of math in life, in science, and all of life? It's simply to observe patterns and go, oh, if that's the pattern, boom, you can jump right to here. That's what math is in the end. It's the science of patterns. And so by the pattern, we can answer hard questions easily, or somewhat easily. Depends how we get the pattern down. Let me enter that one. It is that. So that's exactly it right there. It's good. Are we good? Questions on that? Look at this. I'm going to let you out early.
Mr. Heron.
You can't say I never let you out early. Now, you guys are going to hang